So in this video, we'll talk about chapter 8, rotation of rigid body. So basically in chapter 6, we talk about circular motion. Circular motion adalah pergerakan dalam bulatan. So now rotation of rigid body basically is awak berputar. So it doesn't really matter whether it's dalam bulatan ke, linear motion or whatever. As long as you berputar, you are undergoes rotation. So for example, kita ada your wheel in your car tu kan, the wheel in the bus or something lah. Bila wheel tu basically dia punya adalah berputar. Bila you campak bola bowling, you main bowling, bola bowling berputar. And then when you look up on your ceiling, you can see a fan. Your fan basically berputar juga. Okay, so basically these are the applications lah. Okay, then we have 4 subtopics in this chapter. In this video, we're going to focus on the first subtopic, rotation kinematics. Okay, basically these are the linear outcomes that we need to cover. Don't worry, it seems a lot, but it's not really that hard. Okay, so basically kita ada first we have angular displacement. Basically is the angle through which a point or line has been rotated in a specific direction on about a specific axis. Specific axis ni basically kita boleh cakap sebagai reference line lah. Okay, reference line ataupun bila x sama dengan kosong. So here kita kata maksudnya any calculation kita akan calculate from reference line. So basically kalau kita kata figure shows a point P rotating compact disc move through an arc length. So this is arc length lah. So S ni on a circular path of radius R about the face axis through a point O. So S ni kita panggil sebagai arc length ataupun linear displacement. Okay. Then theta is angular displacement, R is the radius of the circle. Theta ni unit dia adalah degree dan juga revolution. Dan tetapi SI unit untuk theta adalah radian, rad. Okay, means that S equal to R theta. If your S is in unit meter, radius adalah unit meter, theta awak ni kena akan dapat dalam radian. Okay, so SI unit adalah radian lah. So means that whenever you want to use this equation, you need to convert your angle dalam radian dahulu. Okay, so kalau revolution, dia bagi revolution, satu revolution equal to 360 degree and also equal to 2 pi radian. Then kita ada angular velocity. Okay, angular velocity which is omega lah, kita ada dua. One is average angular velocity, which defined as the rate change of angular displacement ataupun instantaneous angular velocity, the rate change of angular displacement. Okay, kalau average, how do we know which one is ours? So for average, dia akan bagi range of time. So katalah dia bagi t equal to 0 second to t equal to 5 seconds. So if you are given 2 times, means that they are asking for average angular velocity. Instantaneous pula basically is which is angular velocity at a certain time. So kalau instantaneous, dia bagi 3 equal to 3 seconds. What is the angular velocity? Okay, another thing, angular velocity also can be called as, sometimes they ask for angular frequency. It's the same thing. Okay, it is a vector quantity, means that it has magnitude and also direction. The unit is radian per second, revolution per minute ataupun RPM. Okay, revolution per minute ni adalah RPM lah. Okay, next. Kalau dia bagi RPM, kalau kita nak masukkan dalam equation, nak jadi radian per second, means that we need to convert RPM into radian per second. So revolution basically, so revolution ni kita kena buat ni, 1 revolution 1 kali 2 pi divided per minute, 1 minit 60 saat. So we get pi over 30 radian per second. So in this chapter, you boleh tinggal dalam pi ataupun you can put in the decimal points lah. Okay, then for average angular velocity, means that the rate change of angular displacement, theta 2 minus theta 1 over t2 minus t1. Okay, so theta 2 is final angular displacement, theta 1 initial angular displacement, theta t equal to time interval. For instantaneous velocity, omega equal to d theta over dt. Okay, so for this one, satu lagi saya terangkan kalau RPH, contohnya 1 RPH, 1 revolution per minute, 1 revolution 2 pi per hour, 1 jam 60 minit kali dengan 1 minit 60 saat. So, you akan dapat dalam radian per second. Okay. Next, every part of rotating rigid body has the same angular velocity. Its direction can be determined by using the right hand grip rule. So, tengok kat sini So, katalah you punya finger ni will be the directions of rotation. Okay, kalau dia berputar, katalah in the first picture, you buat jari you sebagai dia punya pusingan dia, sama ada clockwise atau anti-clockwise. Then your finger will be dia punya directions of angular velocity. Okay. Then kita ada angular acceleration. Angular acceleration same as angular velocity. Dia ada dua jugalah, average angular acceleration dan juga instantaneous. Kalau ni dia bagi 2 time. The rate change of angular velocity. Kalau instantaneous, the instantaneous. So same as before. Kalau dia bagi range of time, it is average angular acceleration. Kalau dia bagi 1 time, it is instantaneous angular acceleration. Okay. So basically, it's a vector quantity. The SI unit is radian per second. So if alpha is positive, omega is increasing. Alpha is negative, means that omega is decreasing. Okay, so basically kita ada alpha A equal to R alpha. So A ni adalah linear acceleration. Alpha is angular acceleration. Okay, sama juga kalau alpha positive means that it's accelerate. Kalau alpha is negative, it's decelerating. Okay, then for average angular acceleration, dia buat macam ni. Omega 2 minus omega 1, T2 minus T1. Then alpha instantaneous adalah d omega over dt. Okay, directions of angular acceleration. If the rotating is spinning up, alpha and omega is in the same direction. So, kat sini, dia makin laju, alpha omega sama. But kalau dia slowing down, basically sama juga, cuma because slowing down, alpha dia will be in opposite directions of omega. Okay, then kita ada relationship between linear velocity and also angular velocity. When a rigid body is rotated about rotation axis O, every particle in the body move in a circle as shown. So basically semua partikel ni, kata rigid body is this one yang warna orange ni. Okay, bila dia berpusing, semua partikel dekat kita punya objek ni bergerak sama sekali. Okay, the directions of linear velocity always tangent to the circular path. So bila dia berpusing, velocity kita sentiasa tangent. So kalau dekat sini, dia macam tu. Ni lebih kurang chapter 6. Nampak tak? Okay, so point P move in the circle of radius R with the tangential velocity. So tangential velocity ni kita boleh panggil sebagai linear velocity jugalah. Its magnitude is given by V equals to ds over dt, S equal to R theta. So V equal to R omega. Same as before. Kalau V ni dalam ms negative 1, R mesti dalam meter, then omega you akan dapat radian per second. Means that whenever you want to use V equal to R omega, omega must be in radian per second. Every particle on the rigid body has the same angular speed, okay, magnitude of angular velocity, but the tangent rate speed is not the same because the radius of the circle changing depend on the position. So, maksudnya, katalah you ada position P, then you ada position, kata kat sini is Q. Means that omega at P sama dengan omega at Q. But, linear velocity P tak sama dengan linear velocity of Q. Because linear velocity depends on the radius from you punya this one, dia punya O ni. Okay. Dan kita ada analogy of linear motion with rotational motion parameter. So basically linear motion dengan rotation ni lebih kurang, cuma dia sama tapi tak serupa. Okay, so kalau tengok theta lebih kurang sama dengan S. Omega naught, this is omega naught tak perasan, lebih kurang dengan U, which is initial lah. Omega naught is initial angular velocity, U is initial velocity. So omega is equivalent to final velocity, alpha is equivalent to A. So how we make it equal? S equal to R theta, V equal to R omega, A equal to R alpha. Okay, kena ingat that theta must be in radian. So because kita punya syllabus alpha and A is always constant, dekat sini lah constant, then semua equation kita boleh equate kan. So V equal to U plus AT equal to omega naught plus alpha T. Okay, so base is equivalent lah, sama sahaja. Equation sama, just we just change dia punya parameter. Okay, so example 8.1 ni is exactly the same as you punya lecture notes. Okay, you are given the equation for omega. Okay, average angular acceleration between 2.2 seconds and 4.8. As I said, kalau dia bagi range of time 2 times, then you need to calculate the average value. So first, average angular acceleration adalah sama dengan omega final over minus omega initial divided by the range of time. So omega final, omega tu time tu kita masukkan sebagai 4.8 square, cube 4.8 square. So omega final dapat 80.3 radian per second. So omega initial 8 kali 2.2 square cube minus 2.2 square. So omega initial dapat 862 radian per second. Then average angular acceleration omega final 80.3. Saya terbalik lah, maafkan saya. So sekejap, sorry salah lah, maaf. Okay, so omega initial dulu 8 kali dengan 2.2 kuasa 3 minus 2.2 square, you get 80.3 radian per second. Then omega final is 4.8 cube minus 4.8 square, we're going to get 862 radian per second. So average angular acceleration final 862 minus 80.3 divided by the range of time 4.8 minus 2.2, so you're going to get 301 radian per second square. Okay, second one is instantaneous angular acceleration at t equal to 3 seconds. So 3 equal to 3 seconds, so alpha equal to d omega over dt. Okay, basically it's a simple equation, so you can just differentiate it. Okay, so 3 kali 8 t square minus 2t. It's 24 t square minus 2t. So you sub the value for 3. 24 3 square minus 2 times 3. So you get 210 radian per second square.